Hi, welcome to Linux channel. So, I always share and discuss in various episodes. I get lot of queries from viewers, especially to my LinkedIn account or WhatsApp, or also sometimes in YouTube queries. These are queries related to their career, and this is since I mostly cover various systems, software development, and kernel software development. So I do get queries, guys who are already working in embedded software, or somebody who is a fresher, and some who are a beginner or a complete fresher or still a college studying student, asking about what to do as I get to this domain and stuff like that. So it can be somebody who is working or going to work or interested to work in device drivers, some customization, bootloader and board bring up, and various things like that, or someone who is just working in microcontrollers. So he has substantial industry experience, but he want to touch upon various other systems aspects. So this is where I thought I can give a an overall overview, so that I can put a sort of a way where we can relate all these domains together, and we can find a common ground, and we see that what it makes sense in case if you upskill yourself and learn these aspects, so that you get somewhat down the lane in your career, you'll have some essential skills to carry forward. Okay, so let's just summarize what I mentioned. Okay, we can take skills like generally embedded development. As we can break down, this can be software, hardware, and it can go forever. So let me just put it in a general terms, and let's assume it is mostly in terms of firmware, software, and such customization, things like that. And it can be also somewhat comprising this OS customization, or it can be even like I mentioned, it can be even a bootloader and stuff like that. So we can just put bootloader, and this is customization. This can also include this Reacto and such build route and such workflow. Okay, so this can be something like that. And apart from that, we also get somebody who is interested in device driver, and somebody who is just working in nothing but some sort of a microcontroller programming, so various aspects like this. See, the big problem with generally the systems software domain is it is quite vast. It's not like you often find with the UI development and any of this AI and ML stuff. So let's imagine you want to be a UI developer. Of course, you can become a complete full-fledged full stack developer. So let's just take this as an example, and then we can go back to system software development. So in the case of UI expertise, you may learn some front-end tools and languages that includes even JavaScript and stuff like that, and all this Node.js and Angular and stuff like that. And when it comes to the backend, you may learn about MySQL and all that stuff. And of course, you need to take this data and represent. So in my case, I use extensively PHP. You may use some other programming language, and of course, to present it, you need all the HTML, CSS, and all those fundamentals. So this is the path for a full stack developer, and as he goes forward in his career path, he may learn various libraries and stuff like that, so he may incorporate into his project. So he just going to learn various upcoming new libraries, and he will incorporate. So this is how his journey is. Okay, but when it comes to system software development, it is so vast. Sometimes apart from that, somebody may expect you to be good in this along with any networking network software development, okay, something like that. Apart from that, somebody may expect you into kernel programming and things like that. So it is quite vast, it's very vast. So let's just put something which is somewhat common, and it will act like a glue, okay. So what I propose is, you can have core system software development skills, which, okay, let's just first let me type this core system software, system software, which includes any user space stuff, and also it includes kernel space stuff. And of course, when I say kernel space, of course it is going to include any device drivers and stuff like that, which is applicable to a Linux like architecture, because the drivers are going to be inside the kernel space, okay. So let's just put something as a perimeter of this stuff. So as you can see here, core system software, user space and kernel space. And if you now see various other aspects, if you do any OS customization and Yapto and stuff, it is somewhat comes like this, okay. End of the day, you are going to do something which is going to touch these aspects also. Same way, this embedded development, again, this is going to somewhere, it is going to bisect this core system software development. And same way, device drivers, where do you do device driver if in case your OS is Linux kernel, okay. If you are going to do in the kernel space, so you need to first be a kernel developer, and then you need to be a device driver developer, like I mentioned in most of my videos. So these days, again, it's like a Venn diagram. This is going to come somewhat like this. Same way, microcontroller programmer, sometimes he may need to do something on a board which has an operating system which is also interacting with a microcontroller, okay. So in that case, you may expose something, and the OS drivers may end of the day talk to that microcontroller and stuff, who knows actually. So you can take anything as an example. You can have some sort of Ethernet controller which is also hooked to the OS, and so the drivers are talking to that controller, who knows. So hence I'm saying, or else it can be an independent microcontroller, right? So something like a refrigerator, washing machine, a board, or a chip controlling the same, and also it is talking to some other chip which is actually going to have some operating system, who knows, okay. So something like that. So it can be an entire thing in a single SoC, okay, which also contains your CPU and stuff, and some sort of dedicated microcontroller, or it can be a complete an ARM processor and stuff. It is going to have a CPU, and it is going to run the OS, and it may be interacting with separate other dedicated microcontrollers. So it can be either of the case. So this is all in single SoC, whereas in this case it is an SoC, but it is not including this other microcontroller. So in this case, so we just don't know, as you traverse across your career path, we just don't know. Sometimes you may be required to work in both the ends. Sometimes you may be required, or you may be gaining lot of expertise in this alone. Somebody may do this work, who knows actually. So as and when the time comes, we never know. Okay, you may still require to know some of these core fundamental skills which are part of the general system software development again. So as you see here, in some ways it's going to still bisect even this. Same way, kernel programming, it is what a part of system software development. So it is definitely, it is this end of the day. And again, if you see the bootloader, again, it's what the kernel loads from the bootloader actually. So there is again some relationship from that to this actually. So hence I'm saying, as a whole, if you take system software development, if you are a core, if you are an expert, or if you are constantly working on some embedded stuff, and if you lack some of the core the system software aspects, let it be user space and kernel space. If you feel that you are not having adequate skills, then you can upskill and you can learn those aspects, and then it is going to balance out. And same way, like I mentioned, if you want to do any device drivers, this is the step one. As you get more expertise, you go towards this, into the device drivers part. So you come like this. Okay, for everybody you come like this. You just learn various systems aspect and user space aspects, and then you come to the kernel space and gain some expertise in kernel space, and then you can go from here. As you see here, device drivers, and as I said, kernel programming is, of course, kernel space is the kernel itself. So you come from user space. Once it is done, then you go to the kernel space, and you can see that. Hence I'm saying this is the glue, which binds various other aspects of overall systems, software development. So if you ask me, I do, extensively network software development. I even do custom protocols and stuff like that. Sometimes I have done in kernel space as a part of my traffic squeezer. Now I have moved the same code from kernel space to user space, completely changed the architecture, and I have done various changes. But it is still a packet processing engine in the user space instead of kernel space. So it still falls under the category of system software development, because there is no application something like that it is doing this packet processing. Although it is in user space, it is substituting the kernel's job and it is doing in the user space, so that I can better optimize the overall architecture of that offering. Hence I am doing in the user space, because kernel space entirely is a different workflow. So let the code be in user space, let the code be in the kernel space. It is still a core backend code. Hence it comes under the category of system software development. The overall solution is a network based WAN optimization solution. Hence it is a network software development, but it is not some regular socket programming garbage actually. So it is not that actually. So it is lot of systems aspects are there. It can be done in kernel space, it can be done in user space. Overall still I claim that it is a part of system software development. Of course I have various other UI components to control the same, to monitor the same, but still if you see the core of the Toffee project, so when I say Toffee, it is the user space of traffic squeezer, the old traffic squeezer. When I say traffic squeezer, it's the old traffic squeezer which existed many years back in the kernel space. So I'm just giving this as an example, so you can better position yourself as an architect. I'm saying you can better position yourself as you gain more and more years of experience in the industry. Let's imagine you do a very isolated microcontroller programming. After you reach around 30 to 32 or 35 years, the problem starts. The industry expects you to have a good know-how in the OS internals and stuff like that. Again, when I say OS internals, I am not saying this general college level approach, what is a scheduler, what is a process, all this bullshit. I am saying the OS level know-how is you are one step much beyond that, and you have good grip in a reference OS such as a Linux kernel, because the most popular operating system which is in the world is Linux when it comes to kernel development. I'm saying okay, I'm not saying desktop OS which is better, whether it is Windows or Linux. So in that aspect I'm saying, since Linux is widely used, we can take always Linux as a base reference, and then we can check our skills, what we have versus what as a sample reference, how it is approached in a Linux kernel. So if you take any core operating system or a general operating system book, there are various concepts, okay, how Linux implements this. Okay, some of the things which are described in the book may not necessarily done in Linux kernel, but you can take a Linux kernel as a reference OS. It is an example you can take and you can learn and gain mastery. So hence I'm saying, if you are working completely away from operating system or any sort of this layer, you are working on this for few years, at some point of time you may be required to have some skills of this as well, because this balances you out. Same way, if you are doing this general OS customization and Yocto stuff alone, at some point you may be required to know the kernel space modules, I mean kernel space architecture and stuff like that, so that in case, as you do here, if you find any issues, if you have any issues over here, you will have some know-how. Or if you do any board bring up, if you are doing any OS porting and stuff like that, let's just put those things. So this can be even board bring up, or this can be even kernel porting and stuff like that. So some of those aspects, so it can be even those things. Again, you see there the overlap is here, we can overlap like this, okay, because when you do this kernel porting, you are porting from one architecture to other architecture or to a new board, who knows. Actually, again, you need to know this aspect. So this is what I feel, it's a binding stuff, it's like a common binding stuff or a glue which almost binds this whole domain. So it is so vast. As you see here, it will diverge from here, okay, when you see here, it will diverge, it will go to its own territory. And if you are more in towards this board bring up and kernel porting, and also goes towards here deeper. So I am saying, same way device driver, again, if you get more and more mastery over this domain, it again goes much deeper, okay. So I am saying, so this is how I see, okay, this is my perspective. So you may agree, you may not agree, but this is how I see. Hence, this is the common binding base skills you should have, and you should have something on these things more on hands-on way, not just in theoretical aspect. So something you keep learning about various aspects, it's not like that. You should have very good in terms of hands-on you should have real hands-on about these things, because if you are already a working professional, you know what I meant. If you are a student, what I'm trying to say is, it's not just some bits and pieces of knowledge you have. The industry expects that you have a knowledge which you can quickly put in practice, okay. Same way, if you gain more and more years of career experience, either of course you can manage a team or lead a team and stuff, or else if you are getting towards more on architecting the entire solution and stuff, then you need to have very good grip on these aspects, so that you can see that how you can optimize and architect a solution. Hence I'm saying, so where, when, how to use is the job of an architect, okay. Hence I'm saying, some of these footsteps taken at early stages of your career is going to help you in the long run, okay. So every time if you gain mastery of this, you see here, you come from here and you know somewhat how the system works, and then slowly you come towards here and go deeper towards this direction, okay. Same way, kernel programming, you learn about overall about systems, play around in the user space, then come to kernel space, play around in the kernel space, then go much deeper into kernel programming. So you come again like this, and then this goes much deeper, and it takes several other branches, let it be towards memory, let it be towards CPU or process, things like that, or any other subsystems. So same way like this, if you come here, network software development, but if it involves more core protocols, layer 2, layer 3 protocols, they are going to exist in kernel space most of the times, and hence, since they exist in kernel space, there is always this Venn diagram sharing will happen. Again, this is going to be part of the kernel space, this is going to be part of user space. If it is application layer protocols, you find mostly in user space. So again, you see this, I can put the same arrow, it goes much deeper. So you can take any number of examples, okay. Let's imagine file systems, and generally about storage. Usually again, this whole file systems are going to exist in the kernel space. Again, the same thing, okay. You learn all these things and you come here, and then you go much deeper into this actually. Okay, and then again if you put a Venn diagram, it is going to bisect this. So you can now understand what I am trying to say. So gain some expertise on this, which is more common towards all these other directions. So from here you can go there, you can go here, you can go here, you can go here, stuff like that. So hope this video helps you, and any queries surrounding this subject, as and when I can give this link, you can refer, and hope this helps you. Okay, so if you have any further queries, be in touch via mail or via LinkedIn, WhatsApp or YouTube queries. Thanks a lot for joining me. Stay tuned. Have a nice day. Bye bye.